Good day, sir. So this is the group 9's presentation about evaluating the 6 trigonometric functions given a point on a terminal side and angle. So this is the first example.
Today, we're gonna find the value of the 6 trigonometric function, giving the following. We have the point 8, 5, so we're going to solve the hypotenuse, which is r. Substitute the value then squared it. Add the two terms, and the decimal form is 9.43.
Today, I will evaluate the 6 trigonometric functions of a right triangle. In finding the value of angle theta, for sine theta is equals to the opposite over the hypotenuse, which is equals to 0.28. And for cosecant, theta is equals to hypotenuse over opposite side is equals to 3.48. Next, cosine theta is equals to the adjacent side and the hypotenuse is equals to 0.95. Then, secant theta is equals to hypotenuse over the adjacent side, which is equals to 1.04. The tangent theta is equals to the opposite side over the adjacent side, which is equals to 0.3. And lastly, cotangent theta is equals to the adjacent side and the opposite, which is equals to 3.33.
Next is the second example.
Today we're going to find the value of the 6 trigonometric function given the following points on the terminal angle. We have the points -5 and 2. We're going to solve the hypotenuse, which is r. And we write the solve for r. So for r, and we use to solve this, we have to use the Pythagorean theorem, which is r squared equals x squared plus y squared. Second is substitute the value. R squared is equals to -5 squared plus 2 squared. And the third is simply square these two terms. -5 squared is equals to positive 25 plus 2 squared is equals to 4, positive 4. And next, add these two terms. R squared is equals to 25 plus 4 is equals to 29. To cancel exponent, we need to square both sides. We need to square it both sides, and this is r, and square root of 29 is 5.39 in decimal. And this is the answer in decimal form, 5.39.
So now we will be evaluating the 6 functions. So first we'll be evaluating the sine theta is 1 over square root of 29. Then the cosine theta, which is -5 over square root of 29. Then the tangent theta, 2 over -5. So next we will be evaluating the cosecant theta, secant theta, and the cotangent theta. So the cosecant theta is square root of 29 over 2. And the secant theta is square root of 29 over -5. And lastly, the cotangent theta is -5 over 2. Thank you.
Now lastly, my problem. Today we're going to find the value of the 6 trigonometric functions given the following points on the terminal angle. So you have the point -9, -6 here. We're going to solve the hypotenuse, which is r. Solve for r. And to solve that, we're going to use the Pythagorean theorem, which is r squared plus x squared plus y squared. Substitute the values. Squared it. Add the two terms. And we're going to square both sides so we can get rid of the exponent here. It becomes r, and this becomes the square root of 117. Then we can simplify the radicals into this. Or the decimal form, which is round off to the nearest 100. So this is the value of your r. Now we're going to evaluate the values to the 6 functions. So we're going to go for the sine theta. Evaluate the y, which is -6 over the radius of, which is, now we're going to simplify it, which is square root of 2 over, -2 over the square root of 13. Next is the cosine theta, which is x over r. Well, substitute it again. -9 over. Now simplify, divide it. This becomes 3. -3 over the square root of 13. Next is the tangent theta. Substitute it with y is -6, x is -9. Simplify. This becomes positive, like signs. This becomes 2 and this becomes 3. That's tangent theta. Next is their inverses or the reciprocals, the cosecant, the secant, and the cotangent. Cosecant is r over y, which is 3 over 13. Simplify. This becomes the square root of 13 over 2. -6. Next is the secant theta. It's r over 6 x. Substitute again. Over 9. Simplify. This becomes -13 over -3. Next is the cotangent, which is x over y. Substitute again. Then simplify. This is how you evaluate the 6 trigonometric functions using a point of a terminal angle.